Hello dear student, welcome to Dream Day School. In this video, we do some activity related to this chapter material, metal and non-metal. Okay dear student, so let's now start activity.
Malleability. Take an iron nail, a piece of graphite, a crystal of sulfur and a wire of copper. Beat them with a hammer. What do you observe? It will be observed that while graphite and sulfur break into pieces easily, iron nail and copper wire do not break. However, the shape of iron nail and copper wire changes. On beating the copper wire and iron nail further, they flatten to form thin sheets. Such a property of metals is called malleability. Ductility. The property of metal by which it can be drawn into wires is called ductility. Non-metals are not ductile in nature. Gold and silver are the most malleable and ductile metals. Also, these metals are very shiny, hence they are used extensively for making jewelry. Reactions with bases. Take a beaker containing water. Dissolve 2 or 3 pellets of sodium hydroxide. We get a sodium hydroxide solution. Now pour this solution in 4 test tubes. Label these test tubes as A, B, C and D respectively. Close the mouths of test tubes with the help of a cork fitted with a thistle funnel. Add small pieces of metals, aluminium and zinc granules in test tube A and B. Charcoal and sulfur in test tubes C and D respectively. You will observe that in test tubes A and B, gases are formed, while in test tubes C and D, no gas is formed. We know that zinc and iron are metals, whereas charcoal and sulfur are non-metals. Bring a burning matchstick near the mouth of each test tube. What will you find? You will find out that gases formed in tubes A and B burn readily, but nothing happens in tubes C and D. Thus we conclude that metals react with bases to produce hydrogen gas and metal oxides or hydroxides. Displacement reaction. A substitution or displacement reaction is a chemical change in which atoms of one element replace the atoms of another element from the molecules of a compound. Let us take up an example. When an iron knife is dipped in an aqueous solution of copper sulfate, a layer of reddish-brown precipitate is formed on the iron knife. The iron from the knife, being more reactive than copper, displaces it from the copper sulfate solution. The copper so separated gets collected on the surface of iron knife. Activity. Take 500 milliliters beakers and add 20 milliliter water in them. Label the beakers as 1, 2, 3, 4 and 5. Add 5 grams copper sulfate to beakers 1 and 2. 5 grams zinc sulfate to 3 and 5. And 5 gram iron sulfate to beaker 4. Now add some iron nails to beakers 2 and 5, copper turnings to beakers 3 and 4, and zinc granules to beaker 1. Then keep the beakers undisturbed for some time and observe carefully. You will observe that the color of the copper sulfate solution changes in beakers 1 and 2. On the other hand, no change is observed in beakers 3, 4 and 5. In beaker 1, zinc Zn replaces copper Cu from the copper sulfate CuSO4 solution to form zinc sulfate ZnSO4 and copper. Because of this, the blue color of copper sulfate disappears and a reddish-brown substance, that is copper, gets deposited at the bottom of the beaker. Similarly, in beaker 2, iron replaces copper from the copper sulfate solution. Hence, the color of the solution changes from blue to green and a reddish-brown substance gets deposited on the iron nail. We conclude that displacement reaction takes place between the more reactive metals to the less reactive metals of salt solution.
You must have all heard the terms metals and non-metals. Can you look around and see if they exist in your surroundings? What is your table made up of? Aluminium or wood? What about the phone or the laptop you're viewing this video on? Is it made up of metals and non-metals? As a matter of fact, it is. Almost everything around will be made up of either a metal or a non-metal.